Hi, my name is Vaibhav Agarwal, and my project is face augmentation using Facebook data. The idea is that there is a camera app which identifies faces in a frame in real time using one of the OpenCV face trackers. And then we use that information to match those faces against Facebook friends' profile pictures to identify who the person really is, and then pull a Facebook information about those people and present it on the frame in real time. This problem is usually known as face verification or face identification problem. Um, so here's a sample of what the app output might look like. So you are trying to take a picture, and at the same time, you can see that the person on the left is a Lokik who likes Linkin Park and Coldplay, and the person on the right is a Lokik's friend who likes to play tennis, etc. So the algorithm to do this kind of face identification is as follows. When you first download the app requests you to log in with a Facebook account and requests your permission to access your profile pictures. It downloads your profile pictures, your friends and friends of friends profile picture, which are public, and then compute features from these profile pictures. Alternately, it could also compute an image embedding from these pictures, which is a different way of classifying them. And finally, it creates a database of these features. Then the online process, which you follow when you're actually taking a picture, is to again use Android API to detect faces in the current frame, and then compute features or image embedding similarly for those faces, and query your database to find their identity, and then augment the face with the identity information. So the first approach I followed was using feature similarity. I tried with SIFT and alt features to train a classifier, and I used the corresponding distance functions to compute matching feature between query and train images, and then homography plus ransack to do geometric verification of the matches. And finally, I used the inlier count as a scoring function and just picked like the highest scored image as the match. So some of the problems with following this process are, first of all, the faces have very similar local features like the corners around the eyes, corners around the lips, hairs, etc. And the second problem is that if you take these similar features and do geometric verification, they turn out to be homography friendly because most people have very similarly placed local features like eyes, ears, lips, etc. So an example here is if you look at the image pair on the right, which is a bad match, you'd notice that a lot of eye features, hair features, nose features got matched to the a person on the right, and the homography yielded a very high inlier count for this image, even though the two people are different. So to summarize the results of the first approach, I used two different kinds of feature extractors, Orb and SIFT, and then I also tried two different approaches. The first one was to just use the full image for feature matching, and the second was to identify faces in the image and use cropped faces for feature matching. And in both cases, cropped faces yielded better results. And SIFT in general performed better than Orb and was yielding 76% accuracy. So I decided to try one more approach to see if I can reach higher accuracy level. I used something called CME's network for training and classification. It's called a 0-1 classification problem, where 0 means that the two images match and 1 means the two images don't match. The idea is something like this. You take a pair of image x1 and x2 and feed it to two separate convolutional towers. The two convolutional towers actually share the same set of weights, and these convolutional towers are used to learn features from these two images, and then these extracted features are passed to a fully connected layer, and then eventually to a loss function. Now, the most important part here is the loss function used. We use hinge loss function here. So the idea is that if you look at the tower on the left, the two images are of the same person. So the output DW should be really small so that your loss is really low. And if the two images are separate, like on the right, your DW output should be really high so that the loss again is low. And that is computed using hinge loss function. So I trained this model using two convolutional layers and two pooling layers, which is max pooling, and then finally a fully connected layer and the loss function. Please notice that the convolutional layers, the convolutional towers are repeated for the two image pairs. Um, and finally got the following results. I trained on 10,000 samples and tested on 2,000 samples. I got marginally better accuracy than SIFT, which is 76.35%, but I believe that there is a scope for improvement by increasing the number of layers or adding more input data.